All right, here we go, guys. In chapter 6 here, we're going to be focusing on systems of linear equations. Systems of linear equations is, it's something that's considered a system when we have, two or more equations on the same picture. And we're actually trying to see where the system has a solution or where the two things have something in common. Two or more things, I should say. So for 6.1, we're going to be graphing these. So we're going to be basically graphing lines on the same coordinate plane, and we're going to be looking for places of intersection. That's the big idea. Where do two lines intersect? All right, so 6.1, that's what we're going to focus on. So to review graphing, I'm going to show you two different ways to think about graphing. Again, we've done this before. But when you see an equation that's like this, okay, this is the ax plus by equals c form. The easiest, well, I think it's the easiest. One of the easiest ways for me to graph this is to just simply plug in zeros. Okay, so if I plug a 0 in for x, I'm left with 4y equals 12, right? 2 times 0 is just 0. So 4y is equal to 12. Y then is equal to 3, right? Because if you divide both sides by 4, you get 3. So when the x value, reminder this is x, this is y, when x is 0, we know the y value is 3. So we can put a dot there. Okay, there's a point there. Then I like to plug in a 0 for my y. So I can say 2x plus 4 times 0 equals 12. This just goes away because 4 times 0 is 0. I'm left with 2x equals 12, so x is equal to 6. Okay, so when the y value, here's the y's here again, when that's 0, the x value is 6. 1, 2, 3, 4, 5. It doesn't look like there's enough here. So 6 is somewhere, over here. And there's your line. You connect the two dots, you got a line, right? The other way to do this is you could solve this for y. Okay, so to get y by itself, we'd have to move the x over, right? So we have 4y is equal to, we could subtract 2x from both sides here, and we'd have negative 2x plus 12. And then we can divide everything by 4 to get y by itself. And we'd end up with y is equal to negative 1/2 x plus 3. Okay, so notice if we graph that, you should get the exact same picture. This is the y-intercept, right, which is right here, and then it has a slope of negative 1/2. So from here, you're going down 1 over 2, down 1 over 2, down 1 over 2, and you end up in the same spot. Notice my other line was a little bit off just because I don't have a super steady hand here, but it's the same line. So there's two different ways to do it. Today we're going to be solving the system of equations, which means there's going to be two equations graphed together, and we're looking for the place that those two things cross when two equations are graphed on the same plane. Here, back to this example, I could just make something up here. I'm just going to make this up. If I had another line that maybe did something like this, right, and went through the origin here, and it hit this line at this spot right there, okay? Where that intersection occurs is at 2, 2. Okay, for today, we're focusing on that spot. We're focusing on where the lines meet. That's called the solution to a system. So if that was indeed the case here, and we had the two equations that created this picture, then this would be our answer, right? So let's do a couple of these. It's going to be considered a one solution answer if the graphs intersect at one point. Okay, so let's try out example 1. Here, it's in y equals mx plus b form, so maybe I'll just use that form and say, okay, for my first equation, this thing here is starting at positive 3, and it has a slope of 2. So from there, I'm going to be going up 2 over 1. And I can also go down 2, back 1, right? And that pattern just continues indefinitely. So I have something like this for my first line. And then for my next one, I'll do this one in blue here. It says that the y-intercept here is -5. 1, 2, 3, 4, 5, so down here. And the slope's -2, so it's going from left to right, it'll be going down. Okay, so it's going down 2 over 1, it'll be somewhere over here off my graph. I can also go up 2, back 1, up 2, back 1. And right there, you gotta make sure you graph until you have a crossing. The crossing happens right here. This point is -2, -1, right? So my x value is -2, my y value is -1, and that is the solution to this system. Now I want to show you something algebraically here. If you were to plug those back in, okay, so if you plugged a -2 back in here for x in this one, and a -1 in here, notice it would work, right? -1 is equal to 2 times -2 is -4, -4 plus 3 is -1. So this is a true statement when you plug that point back in for x and y. Same in this equation. Okay, so we're going to get into more of that next time, but this is the only point that would work in both equations like that. Now, once in a while, you'll have a system in which there's no solution. Okay, this happens when the graphs are parallel, and if you'll remember from previous lessons, parallel lines happen when there's the same slope. Okay, so if you have lines that look like this when you go to graph them and they never cross, that's considered a no solution. So I could say, if I said like y equals 2x plus 3 and y equals 2x minus 3, this would be an example of no solution. How I know that is, same slope, right? Different y-intercepts. These are parallel lines. All right, so that could occur in this lesson, so just be mindful of that. Here, I already know without even graphing this that this is going to be a no solution because they're graphed for y. They're already solved for y, and I know that both slopes are equal to 1, and there's different y-intercepts. Okay, but let's graph it just to make sure. So the first one, if I graph that, my y-intercept's -3, and then I know my slope's +1, so it's going up 1 over 1, up 1 over 1. Okay, and then my other one is at, do the other one in blue here. This one starts at +3, and it has the exact same slope. Okay, so if this pattern goes on indefinitely, those lines will never cross, and since a solution to this is where those two lines cross, this would have no solution as an answer. Okay, there's no place that those will ever cross. Now, infinite solutions, this happens when it's the same line graphed on top of itself, essentially. So here, for my first line here, it's solved for y, right? The second equation doesn't look the same yet, but if we solve it for y, I think we'll see that it is the same. So when I go to graph y equals -3x plus 1, -3x plus 1 has a y-intercept of 1, and then it's going down 3 over 1, up 3, back 1. It looks like this. Okay, and then in blue here, I'm going to solve this for y. So if I solve that for y, I'm going to move the 1 over by subtracting it. So I have -y is equal to 3x minus 1. Okay, I'm going to divide everything by a negative in order to get y by itself. So if I divide everything by a -1, I get y is equal to -3x plus 1. And you'll notice that that's the exact same thing. So if I go to graph that, I would start at +1. I'd go down 3 over 1, up 3, back 1, and it would be the exact same line again. So if a solution is where two lines cross, these two lines cross always, indefinitely. They're the same line. So this is an example of infinite solutions, or all real solutions. All right. So example 2 says graph each system, determine the number of solutions it has. If it has one solution, name it. So here's a little bit of practice for you. I'm going to do the 2A. I'm going to let you do 2B, and then we'll be done with the lesson. So here we go. For 2A, since it's kind of in general standard form here, I'm just going to plug a 0 in for these. Okay, so for this one, if I plug a 0 in for x, I would get -y is equal to 2. So if I divide both sides by -1, I get y is equal to -2. So when x is 0, y is -2. Okay, and then I'm going to plug a 0 in for the y value. So x minus 0 is equal to 2, therefore x must be equal to 2. Okay, so when I plug a 0 in for y on the y-axis, I get an x value of 2. Okay, so there's my line. It looks like I have a slope that is positive when I do this, and it's going up 1 over 1, right? So if I could just fill in some dots here, I get this kind of pattern going. And then let me do my other one here in red. Okay, so again, I could solve for y, or I could plug in zeros, right? I'm going to plug in zeros. So if it was 3 times 0 plus 2x equals 9, I get 2x is equal to 9 because this goes away. And then x is equal to 9 over 2. If you took a calculator and divided 9 by 2, you'd get 4.5. Okay, so when y value is 0, the x value is 4.5. So 1, 2, 3, 4, 4.5 is right in here. Okay, and then if I plug in a 0 for x, I would get 3y is equal to 9. So y would be equal to 3. Okay, so that would be up here. So notice we have this kind of a thing. Okay, but what's interesting about this example is it's not very clear about where those things cross, right? So one thing that you might consider, notice that I plugged a 0 in and I got my intercepts, which is totally valid. What I might want to figure out though is what the slope is of this thing. Okay, so what I can do is I can say, okay, this is going down 3 and it's going over 4.5. If you solved this, you would see that what that is. So if I solve this for y, I would get 3y is equal to negative 2x plus 9. Y then would be equal to negative 2/3 x plus 3. Okay, so it's going down 2 over 3. So I know it's right there. And I know that the blue line also is crossing right there because it has a slope of 1. So this has to be the solution. So you got to be real careful when you graph, because you got to know exactly kind of where those two things meet. And so here I made that a little more clear for you. So the point there would be 1, 2, 3, comma 1. Okay, 3, comma 1 is in common with both, and you could check your answer by plugging that back in. Now it's your turn. What I would suggest here is for this guy, it's already in y equals mx plus b form. I would just use the intercept and the slope. And then for this one, you can either plug zeros in or you can solve for y. All right, so let's just make sure you guys did this correctly here. So for the first one, it would be negative 3 is the intercept. And then it's going down 2 over 1, back 2 over 1. Get something that's looking like this. Okay. And then we'll do the other one, this other color here. Let's solve this one for y. So we'd have 3y is equal to negative 6x minus 9. I just moved the 6x over, right? And then divide everything by 3. Okay, when I do that, I get y is equal to negative 2x minus 3. All right, so if I go to solve that here and put it on there, I would get negative 3 here, and going down 2 over 1, up 2, back 1, up 2, back 1. I get the exact same line, right? So if it's the exact same line, we know that this is all reals. All right, you guys, that's it for this lesson. Homework's 1 to 25 odds. See you next time.